I'm going to talk about a house I built in Creemore. Creemore, many of you probably know because of the brewery. Maybe you've been there. It's about an hour and a half north of the city. Nice village, really. And just to start, for context, I just wanted to talk about site selection. So this was built, call it an infill house. So it's on an established street. They're houses that have been around for 150 years, but it was a vacant lot. So essentially it was 60% grass with a 40% at the back was a vegetable garden. So I did have a bit of a blank slate within a kind of urban context. The lot's quite large. It's about 66 feet wide, 20 meters, and about 186 feet from the street, so including the towns right away. So looking for a lot, among other things, I was looking for a site with good access to the sun. So the fact that, I really wanted a lot that would have a south-facing backyard. Just the large open glass that I like, both for the light quality and the warmth in the winter, as well as the efficiency. For me anyway, I'd rather have that facing into a more private space. So in terms of site selection, I was looking for basically good access to the sun and a building that could have, although it doesn't yet, have really good PV, so virtually unshaded roof. And there aren't that many lots available in Creemore, so I felt I did all right. The layout of the town is, I'll just click. No, that's not going to work. Here, let me try that. I'll do that next. Okay. So the layout of the town, it's turned about 15 degrees off of true north. So the south face of my house actually is turned, so it'd be about 165 degrees, which is pretty good. So like if you were to run it, put your solar array through some sort of calculator, and there are a few out there, it really doesn't affect performance significantly, and it makes it reasonably possible to have fixed shading that works. So there are deep overhangs on the house, and so basically summer solstice, the south windows are fully shaded, and winter solstice, the south glass is virtually unshaded. So anyway, it was a good site for this project and quite level. So that, in terms of construction costs and so on, was a consideration. Trying to minimize how many retaining walls and complicated elements I needed to add to the landscaping. So, so this is the south elevation. The first floor windows, there's a fixed, so it's about a 2-foot overhang, and then the gable roof is about a 2-foot overhang as well. And the project, so the main focus of this talk, I'm just going to give a very brief summary of the house, is in terms of details. Greg and Shervin asked if I talk about some building details. So I've picked the foundation. Just in the time available, it doesn't make sense to try and do too much. So relevant to the timeline of the house is the foundation choice. So it's a slab on grade, and a fairly simple and conventional foundation structurally. So I didn't actually acquire the lot until the end of July 2014, and I had my building permit application in, I think, around August 22nd or August 20th, and then I had my building permit in hand September 4th. So it's a pretty fast timeline. So in terms of something clear and understandable, in some way standard, that fit in with that objective. And I actually had an excavator digging September 22nd. So So in under 2 months, I'd gone from actually owning the lot to being underway. And the choice of foundation fits in a bit with that. In terms of context, Creemore has a very high water table seasonally. So in terms of choosing not to do a basement, that was definitely a consideration. Like a neighbor a few doors down just this past spring, their basement is quite a well-finished basement, fairly recently done. It was basically trashed. The interesting thing is that they had a working sump pump. So the high water event that happened in March was significant enough that their sump pump couldn't move water away from the foundation quickly enough. So they even had a backup generator. They had a Generac, like gas-tied Generac. It didn't save them. So they had a big dumpster. And so deciding to omit a basement, that was a serious factor. And I have a sister who lives out in Calgary, and I think it was 2014. Yeah, it must have been just before building this. I'd been out visiting her in Calgary. Maybe I was out there maybe a week after the significant flooding, and I remember the Bow River was like, it was unbelievable. And I'm sure in the back of my mind, or consciously as well, like the choice to not put in a basement that could flood was part of it. So in terms of a resilient building, the finished floor is about 18 inches above grade, and it would take an unbelievable event for this house to flood. So I can go away in the winter, shut off my water, and basically things will be fine. Or we could have a torrential downpour and be fine. So just some very brief specs on the house. So it's a double stud wall construction with dense packed cellulose. It's about an R50 wall, like the whole wall value is about R50. It's a vented attic, so it's a gable vented attic that's about R80, R90. And the foundation, I'll go into more detail on that. The windows are tilt-turn, triple glazed. I actually got them through Hans, and they're lovely. And it's all electric. There's gas on the street, but it's heated with air source heat pumps, so 2 mini splits. And in terms of air tightness, so it's air, passive house level airtight. And there's a fully ducted Zender HRV installed as well. So that's just a little quick background. It's about 850 square feet per level, so 2 stories, 1,700 square feet. This is interior, and the outside dimensions are more. They're very thick walls, but there's also an enclosed porch that could be heated in the future, and it's about 300 square feet. So for now, it's more of a three-season type space. Okay. So these are the Fujitsu air source heat pumps. So there's the downstairs. They're 2 single head systems. So I didn't do a multi-head setup. This is the the RLS 3 series of Fujitsu, which is great. So now the capacity is rated to -26. They go colder than that. So I have a 12 and a 9, so slightly larger heat pump for the downstairs. And based on only 1 winter of being in the house, it was able to heat the whole house. So it was basically point source heating. And then this past summer, which was hot, like legitimately hot, I used the upstairs unit to cool the house. And so in terms of capacity, these systems are great, which is a nice thing with inverter-based system. It can really adjust its output, and with a very tight building where you're not asking for much. And just on the left, you can see I've got a dual meter base. So the left is obviously me drawing power, and the right is making allowance for future PV. So there's about 800 square feet of very good main roof that I could put maybe 12,000 watts of PV on. and then there's an equal size roof that covers the garage and porch. So if someone in the future had an electric vehicle, you could easily go net zero unless you're a real wastrel. Okay. So I don't have anywhere near the great data that Ed has, so this is kind of embarrassing, but this is, so Collis Power Stream is the local power company that we have in Creemore. And just, I think it was last week, they sent us this little energy report, or power report, I think they call it. So it's a snapshot of the past 12 months. I didn't occupy the building until the beginning of November, really. So those first 2 months on that blue line, 23 Wellington, that's consumption during construction. So it would be power tools, I don't know what. Anyway, the next line, the greenish line, is my efficient neighbors. I think that's the 20% most efficient neighbors. And then the top line is just everybody. And I'm not sure what the hell they're doing to like draw that much power, but like I'm a fairly efficient guy. Like I think about energy, but it's like I have a full-size fridge. I was air conditioning this summer, so it's not like I was living with a flashlight. But anyway, like for August, to me, like someone has some seriously inefficient air conditioning going on. Anyway, that's just a very crude look at the overall consumption for the house. So when I say that roof could get me to net zero, okay, and this was, I think, for the month of August. So I'm doing great. You can see I got 2 happy faces. So that top line is me. So really, really low. And as well, like just like Ed's house, this is an all-electric house. So I'm not consuming propane, not consuming gas, no oil, no coal, just electricity. So without further ado, how am I doing for time?
I think you've got time.
Okay. So there's my very quick, maybe rush snapshot of the house. So the detail I'm going to focus on, like I said, is the foundation, and at the end of that, how I connected the foundation to the wall in terms of the air barrier. So, or at least the primary air barrier. So. This represents, it's going to take a little imagination, this represents a cross-section of the ground before anyone has disturbed the site. Okay, so there's a thin layer of grass. Like I said, it was like 60% lawn where I built and 40% garden, which I kept. So we've got dirt and a thin layer of lawn. I can do this, right? So that's after McDonald Excavating has taken some dirt away. So the footing, so it's a standard footing. The top of the footing sits about 4.5 feet below grade. And then a standard stem wall. So that's about a 6-foot stem wall, which takes the top of that to about 18 inches above finished grade. I'm not sure if you guys have seen these advanced graphics before, but let's just say it didn't take me too long. So after taking the forms off that stem wall, I insulated the interior side of that foundation wall with 2 inches of type 4 EPS. So it's very good R value per inch, so it's over 4. I actually used an EPS that's treated for termites or insects. So I was able to get that directly from a factory in Buffalo. So I did 2 2-inch layers vertically. So they're about 6-foot lengths. So that allowed me to stagger my seams so that to reduce the gappage, right? Next, I backfilled, compacted sand principally, about a 6-inch gravel layer, and getting this level and compacted was important, but not that difficult. All very familiar to the building department in Clearview. So next a 4-inch horizontal layer of type 4 EPS, so the same that I did vertically, followed by a second layer, so 8 inches total sub-slab. And then this represents a 15 mil, so pretty heavy duty vapor barrier, air barrier. They came in, I think it was 8-foot widths, or no, it was 10 foot. So it was folded. So it was a 5-foot roll, really heavy, folds out to 10 feet. So 3 of these lengthwise covered my full foundation. So that 15 mil material, you know, it came, as you can see, it comes across the foam. So I've got a foam bathtub essentially, or tray. It comes up and it goes right across the top of the foundation, and it projects past the outside face of the foundation. So this is an important detail in terms of, you know, how I redlined this project. Like, how do I connect my airtight layer underfoot to my vertical airtight layer, my wall, right? So this represents it being fitted in place, and then the slab being poured. So it's about a 4-inch slab. I didn't put radiant heat or anything. And that slab sits very close to flush with the top of the foundation wall. And I'm now going to show you the, this is, I don't know if you caught this graphic, but this is a zoom feature that I've put in. So I've now zoomed in on that very same assembly. So that is a 2x6 framed wall. It isn't sheathed yet, and if you'll notice, it sits, the outside face of that 2x6 wall sits slightly in from the outside face of the foundation. So it isn't flush. It's set in actually about ½ an inch. And that allowed me to then put a bead of acoustic sealant essentially in that little V, in that little 90. So as my carpenters were, because we're working on the first floor, it's relatively easy. You'd frame a wall and then sheath it because it's lighter. So we're working within 18 inches of grade. So it allowed me to, just before they were placing the plywood, so ½ inch plywood on, to basically work ahead of them and put a bead of sealant, and then the plywood arrives and it basically squishes and embeds itself in that bead of sealant. So now I have a continuous, fairly robust vapor air barrier that spans the whole foundation and is now connected quite easily to the vertical element. So, and there were some other things I did as well, but this is slightly simplified, but gives you the idea. And I'm going to take some photographs to illustrate what I showed you with those graphics. So this is the site looking north, just beginning to excavate. You can see the porta potty and some older homes. So those are probably 1920s homes. There's one that was, I think, 1850s to the right of that. So footings. This is, I've jumped a couple steps, so now you can see the 6-foot stem wall is poured with the two 2-inch layers of vertical EPS that run basically the top of the footing. And flush, excuse me, flush with the top of the wall. This is in the process of finishing the leveling of the gravel and laying the first 4-inch layer of sub-slab insulation. This is, we've jumped ahead a few steps, so this shows the pouring of the slab. So you can see there are really only 2 seams. By getting a wide, 10-foot wide material, basically I had 3 rolls of the stuff and this tape, which was pretty solid. So basically 2 seams that were very simple to tape. And this is the framed wall. So this is the outer load-bearing stud wall. There's an inner 2x4 wall as well, which I'm not going to show you. And that shows the 2x6 plate, bottom plate, sitting essentially on the vapor barrier. And that is the sheathing, and it's really the sheathing that I care about. Like I use that cheap pink foam gasket stuff that often is used for air sealing a wall-to-floor connection. It was there just because. Like I think I got it for free from the building supplier, but I wasn't relying on it to do anything. So it's this connection principally that I was counting on to make that transition. So you can see the black acoustic sealant has started to ooze a little. So I knew I had pretty consistent application. And you know, in terms of why doing it, I've mentioned most of these things, but you know, there's a lot of topsoil on this site. There's about 3 feet of it. So different foundation systems would have probably required removing that anyway. So that's minimizing site disturbance is a real advantage of certain types of raft foundations and other approaches. So this site was probably going to be disturbed. You know, the familiarity with the building department, so they could look at it and talking to, you know, local concrete contractors, all of that. It was all very familiar. And another advantage is that exterior insulation is sometimes difficult to protect. Like you see, often it's, you know, cement board and stuff, and it can be done. But it, you know, on the side of doing a stem wall, the concrete is the finished exterior. So, you know, I could use it to put ledger boards on for my decks, really robust, and that's it.